Hi, I am Rashani DeBell, and you are learning algebra. Hi everyone. In today's lesson we are going to talk about systems of linear inequalities. Let's go ahead and get started. Solving systems of linear inequalities. Our objective is to graph and solve systems of linear inequalities in two variables. What is a system of linear inequalities? A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. Remember, in inequalities, you have a less than or greater than symbol or a less than or equal to or greater than or equal to symbol. The solutions of a system of linear inequalities are all of the ordered pairs that satisfy all of the linear inequalities in the system. Here are the steps to graphing and solving linear inequalities. First, rewrite the equation in terms of y. So think about y equals mx plus b. Graph the boundary line. Use a solid line if it's less than or equal to or greater than or equal to. Use a dashed line if it's less than or greater than. If y is greater than or equal to, shade the half plane above the line. If y is less than or equal to, shade the half plane below the line. Don't forget to check your answer. Before we move on to an example of graphing and solving linear inequalities, let's work through some problems where we have to check an ordered pair. We're going to work through the first problem. We have a system where y is less than negative x plus 4 and y is less than or equal to x plus 1. We are asked to check that this ordered pair 2 and 1 satisfies the inequalities in this system. Remember, your first number is always your x and your second number is always your y. To check the solution or this ordered pair, plug it in to the equation and see if it makes it a true statement. So I've got 1. Is that less than negative 2 plus 4? Negative 2 plus 4 is 2. 1 is less than 2, so yes, it works out for the first system. Remember, you gotta check both. So I have 1. Is that less than equal to 2 plus 1? 2 plus 1 is 3. And yes, 1 is less than or equal to 3. And so for the first one, yes, 2 and 1 is a solution. Let's work on the second problem. I have y is greater than or equal to 2x and y is less than x plus 1. And I'm asked to check the ordered pair 2 and 0. So I've got x and y. Going to plug in. So I've got 0 is greater than or equal to 2 times 2. 2 times 2 is 4. 0 is not greater than or equal to 4. So right there we can stop and say, no, 2 and 0 is not a solution to this system. Now let's take a look at some examples. In this example, we are asked to graph and solve the system of linear inequalities. We're given y is less than 2x plus 2 and y is greater than or equal to negative 1/2 x minus 1. We're going to start by graphing the inequalities. Each of these inequalities are already written in slope-intercept form, which is y equals mx plus b. So we're just going to identify our slope and our y-intercept. In our first equation, our rise is 2, run is 1. Remember, this is the number by x. Our y-intercept b is 2. This is the number that is by itself. So I'm going to start my graph at y equals 2, which is right over here. Since it's a positive slope, I'm going to go up 2 and over 1 and continue doing this. I'm also going to go down 2 and over to the left so that I have a positive slope. Since this inequality is just a less than and not a less than or equal to, our line over here is going to be a dashed line, meaning that none of my solutions will be on this graph. Since y is less than 2, I am going to shade below the line, so it's going to be on this side over here. Now I'm going to graph this equation over here. Y is greater than or equal to negative 1/2 x minus 1. Start by identifying my slope. It is always the number by x. M is equal to negative 1/2, where I have a rise of 1, run of 2, and it's a negative slope. And my y-intercept, I start at negative 1, which is right over here. And then since it's a negative slope, going to go down by 1 over 2 and continue. Because this is a greater than or equal to, my line is going to be a solid line. The solid line indicates that my solution can be on my graph. So it's any point on my graph. Because it is a greater than, it's actually going to be on my graph and above my graph as well. So to figure out the shading, y is greater than or equal to this negative 1/2 x minus 1. Since it's greater than, I am going to shade above my line of y is greater than or equal to 1/2 x minus 1. My solution to this inequality is where the two shaded regions overlap. As you can see, it is in this area over here. I can check my work by choosing a point within the shaded region. So it looks to me like I can choose this point over here, 0, 0. So I'm going to check with 0, 0. X is 0, y is 0. So it's using the first equation. So I have 2 times 0, which is 0. 0 plus 2 is 2. 0 is less than 2. So yes, that works. Have to check the second equation as well. 0 is greater than or equal to negative 1. So it checks in this one, yes. And therefore, you can see that this point over here is a solution. It's in the shaded area and is a solution to the system of this inequality. We can also check by taking a point that's outside this shaded region. In order for this to work, since it's outside the shaded region, when we check it, it will make one or both of the inequalities a false statement. So I can say, for example, I choose this point over here, negative 2 and 2. So this check was with 0 and 0. Let's check with x equals negative 2 and y equals 2. So I have 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. 2 is not less than negative 2, so not a true statement, hence the reason why this area is not shaded. And you can do that with other points outside the region as well to check to see if it makes a false statement, and if it does, there is your correct answer. In this second example, we are given a set of 3 inequalities that we are asked to graph and solve. In this inequality, we are told that y is greater than or equal to negative 3. This means that this is a horizontal line going through the point negative 3. Our slope in this case over here is 0. So I'm going to look for y equals negative 3, which is right over there. And this is just going to be a horizontal line. It is also going to be a solid line because it is greater than or equal to. Since y is greater than or equal to negative 3, I am going to shade this region above my line of y is greater than or equal to negative 3. I'm now going to graph the line of y is less than 2. Y is less than 2 is a vertical line going through the point 2, which right over here, x equals 2. Since it's just less than 2 and not less than or equal to, this is going to be a dashed line, meaning that my solution would be any number that's less than 2 but not 2 or greater. To shade the region, y is less than 2 is any region that is to the left of my vertical graph, y is less than 2. And finally, I have this inequality here, y is less than x plus 1. My slope m is the number by x, which is 1 over 1. It's a positive slope with a rise of 1, run of 1. My y-intercept b starts at 1, so I'm going to start at my graph at 1, rise 1, run 1. Since this is less than, I am going to draw a dashed line to show that my solution is not on the graph of this line, but it is below the line. Less than means I have to shade below the line, so it's got to be this area over here. Our solution to the system is where all of these 3 colors overlap, which is in this triangular area over here. And we can check. Again, notice that 0, 0 is inside our shaded area, so that's the best point to use to check our work for all 3 equations. Is 0 greater than or equal to -3? Yes. Is 0 less than 2? Yes. Is 0 less than 0 plus 1? Well, 0 plus 1 is 1, and 0 is less than 1, so yes, it works. And therefore, our solution is this shaded region. Again, you can choose any values outside the shaded region and check to see if it makes any of these statements a false statement, and if it does, you should not have this area shaded. And there you have it. Our answer to this inequality is in this triangular shaded region. And that is how you solve a system of linear inequalities. Thanks for watching.